Okay. In last class, we have seen uh, cancer, different types of cancer, then uh, carcinogenesis, proto-oncogenes, gene level therapy, sorry, hallmarks of cancer we have seen. So that was the basics for the cancer. Now we want to see the treatment, how it works. For the treatment of cancer, single method of treatment will not be satisfied. You need to do multiple treatment, especially radiation therapy, chemotherapy, and surgery. These three combinations nowadays more widely used: chemotherapy, surgery, and radiation. Three combination therapies can be used for the treatment or for sustaining the cancer to a cancer patient. Nowadays, no, there are some more therapies has come. hmm, uh, Endocrine therapy, immunotherapy, targeted therapy, stem cell therapy. These also new, they're coming. But these three therapies, what is that? Chemotherapies means the chemicals we use. Radiotherapy means radiation we use. Radio gold, hmm, radio iodide, platinum compounds. Uh, some of compound we can use it, but uh, it's very dangerous at the same time. All are dangerous. Surgery, that is also is done in combination. Hmm? Rarely single therapy is effective. So that's why multiple modalities are utilized to control cancer. The best way, the best practice, what is going on now is radiation, chemo, and surgery. Other methodology is also involved. It's endocrine therapy, immunotherapy, targeted therapy, stem cell therapy. Huh? This endocrine therapy is for maintenance of life. For maintenance of life, what happens now? They improve appetite, they decrease vomiting sensation. They improve what is the stomach linings. These are the some of the advantage with endocrine. Then immunotherapy, we have seen that what is that? Cancer cell escapes, evades what is that? Immunology. There it plays very important role there. But still research is going on. Few drugs came into the market, but still it is in a, what's that? What we can tell is that it is in budding stage only, we can tell. Then target therapy is also same. Sometimes it is successful, sometimes not. Stem cell means especially for chemo. What is that? Leukemiasis. In fluid cancers. In fluid cancers, there we can use this stem cell therapy. Total stem cell is removed and added new one. These are the some of the therapies. But we will be dealing with chemotherapy for us, then endocrinology. We don't read surgeries, radiation therapy, that for us. No. So chemotherapeutic agents. They are also called as antineoplastics, cytotoxics, cytostatic, anti-tumor, or anti-cancer drugs. So multiple names are present for chemotherapy: antineoplastic, cytotoxic, cytostatic, anti-tumor, anti-cancer. They show activity only on cells in the process of cell division. How they act? Where they act? They act on the cells where the active process of cell division is occurring. So this is cancer cell. For example, you see, this is cancer cell. Simple representation I am telling. For layman purpose, how it acts, we are explaining in this diagram. So chemotherapy, when you give a drug chemo, cancer cell, you see, it is highly active in nature, red in color. But when you give chemo, what happens is that they reduce size. Here you see, if you count the cells, see 7 were there. Now it became 3. It became 3. So the dose levels, the doses of these drugs are so micro in nature. It has to be handled with uh, artificial intelligence and with robotic. It has to be handled. All the instruments only, you can see it here. You see, to this girl, the instruments are delivering the dose. They tell 1 ml, 1 mg per ml for 24 hours. 24 hours. Slowly it will be released because they're very toxic. These chemo drugs are very toxic. You can see sometimes I have seen in hospital dopamine. Dopamine given to the patient for 24 hours, 1 ml injection. 1 ml injection, 24 hours they are giving, slowly given for heart patient. I forgot to tell you. We have learned last year propofol. What is the use of propofol, please? Anyone? Anyone, please, in the class? My God, not even a single person.
General anesthetic.
Hmm?
General anesthesia.
General, very good. Kelvin Chai, good. I think many people know, but they don't want to tell. Good. So general anesthetic. I was telling that it is very painful injection, and you will get for short duration of anesthesia, for short duration. Last Saturday, last Thursday, I told you that there is no class. When they're done for me endoscopy, they given propofol. Really for 10 minutes. Uh, when they started giving injection to me, I was shouting, it is very pain, very pain. Please stop like that. But only that 2 sentences. After that, I don't know. Really, it was very painful. I don't know how our Michael Jackson favorite guy used to take every day that drug. So if you actually go into the hospital, you will learn. You will learn. So whenever you are going for rotation, devote yourself to learn as much as possible. See all the instruments surrounding the patient. What is that? You need to talk to the um, doctor or nurse very politely and grab the knowledge from them. Okay, so the cells with high percentage of cell divisions are more susceptible to chemotherapeutic agents. But disadvantage here is that normal cells that divide rapidly are affected. There are some normal cells which are rapidly dividing in our body. That is hair follicle, mucous membrane of the stomach, WBC, etc. GIT, stomach lining, for example, these also get affected. So what happens is that when hair follicle comes, he get uh, baldness of scalp. Then mucous membrane of the stomach gone means what happened? Diarrhea. Uh, all the useful bacteria will go. Even if you use 1 or 2 doses of amoxicillin or antibiotic azithromycin, you get diarrhea. So this is very dangerous. When WBC goes down, what happens? You become weak. You become very weak, and what is that? You get more infections again further because white blood cells are like police people for us. They monitor foreign substance for us. So that is also is going down. It's very dangerous for us. So let us see. So classification of drugs. Classification of drugs. Children, I am telling again. See, this is simple classification, but when you can see it, and for example, alkylating agents. Now in nitrogen mustard, again 5 drugs are there. Nitrosoureas, some 2 to 3 drugs are there. You need to mention them again. If I ask classification of chemotherapeutic agents, do not mention like that. Do not mention. Detailed you mention. Detail you write. Detail you write, please. So here I given generally. Then what happens in alkylating agents, when we take separately nitrogen mustards, we will read about them, totally 5. In nitrosoureas, carmustine, lomustine, 2 drugs are there. Alkyl sulfones, bus sulfone is there. Aziridine, trizine, platinum complex. Platinum complex. There are some 5 to 6 drugs in platinum complex. So there are examples for these. In one slide, I can't put I can't place all the details here. So I given only the titles. When I ask in examination, if you write this, I can give only half mark. Then anti-metabolites. Then folic acid antagonist. There are some methotrexate. 3 drugs are there. Purine antagonist, pyrimidine antagonist. Then anti-tumor antibiotics. There are separate. Then natural products, vinca alkylates and antibiotics is there. Hormones, miscellaneous drugs are present. So this is the classification of chemotherapeutic agents. We will read further details whenever we are studying in subtopics. Anyhow, by by mid semester we will complete this, at least up to here natural products we will complete. Now let us see one by one. There is one more classification of drugs. One more method of classification is cell cycle specific drug. Classification of drugs according to cell cycle specific. You know this, I guess. Here you see, this is the cell cycle. The cells will undergo this process of cycling. Now, here, this is M phase, that is mitosis phase. Mitosis phase. Now, M phase, after mitosis, it comes to G1 phase. G means gap phase. G means gap phase. Now, after G1 phase, the cell goes to S phase, that is specific phase. Now, where DNA is synthesized. And so whatever the enzymes required for S phase is produced in G1 phase. That means the cell gets equipped in the G1 phase. In the gap phase, don't think that it takes rest completely. In that gap phase, what happens? No, the cell gets all the enzymes, necessary hormones, everything necessary for the specific phase. Next, after that, it moves to G2 phase. G2 means second gap phase. Now, here it also gets equipped all the requirements necessary for M phase. Then, after that, after M phase, it goes to G naught phase. Sometimes it goes to G naught phase. Again, after G naught, it is no further division. G naught means no division. Sometimes it can come again back to G1 phase. G1 phase. Here you see in G naught phase, some of the cells, for example, nerve cells, muscle cells, they go after cell division, they go into G naught phase. G naught phase. Nerve cells will be the same at the time of your birth. If the nerve cells are 7,000, same will be till your death, or sometimes they may go down. Muscle cell also same. Muscle cell size increases, it increases, atrophy increases, but the muscle will be the same. Chick will be the same even at the younger age or at the child age, but the size increases. So that phase is for them, no, they are in continuously in G naught phase. But normal cells, for example, white blood cells, they may go for few seconds or few minutes depending upon the type. They go to G naught phase and they may come again to G1 phase. So this is how the cell, normal cell will go in cyclic form. Now there are some drugs which act at these phases. At these phases. Here also you can see it. S phase means DNA synthesis. That's why it is S phase. DNA synthesis is occurring. Now you see in G naught phase, what I told you, the cell gets equipped, I told. Here you see synthesis of cellular compounds needed for synthesis of cellular compounds needed for DNA synthesis are produced in G naught phase, sorry, in G1 phase. Next, in after S phase, after S phase, what happened? Synthesis of cellular component for mitosis, tubules formation, spindle formation, everything, or RNA formation, protein formation will occur here. The cell components is doubled in G2 phase. Then after doubling, then it undergoes mitosis. It undergoes mitosis. So what happens is that, suppose if this is the cell, what happens? Nucleus size is increased, not nucleus size is increased, doubling the contents. Not number 2. 2 nucleus will not be present. 2 mitochondria will not be present. Mitochondria size will increase. Then M phase, what happens? The cell will divide. This is it. Now what happens is that there are some drugs which block at M phase. You see, taxanes. I told you plants, no? Here they are coming. Taxanes, docetaxel, palsitoxil. These are the examples of one plant derivative, taxanes. Then vinca alkalides, vinblastine, vincristin, vinerilobin. These are. At G1 phase, the drugs which act here is hormonal drugs. Then enzyme drugs will act at G1 phase. Then there are many drugs which act as at S phase. All anti-metabolites. See, metabolites means food materials. Food material, that is folic acid, purines, pyrimidine, they are food. Metabolites for our byproducts for our food. If the food components are not there, in last class we learned that cancer cell takes lot of energy. So if you deprive them, what happens? Automatically the cell becomes weak and dead. So all antimetabolites Huh? What we learned in S phase, DNA synthesis, we told. DNA is synthesized, we are telling. Now, when we deprive these metabolites, no DNA, folic acid is very important. Purines, adenine, guanine. We told G will bind to cytosine. Cytosine. No guanine means what? No cytosine, pyrimidines. No cytosine means what? No DNA. That is happening here. But these are very beautiful drugs, but at the same time, they were not able to differentiate between normal cell and cancer cell. That is the main issue here. That's why patient, I told you the last sentence of this last class, it is easy to kill the cancer, but what is the strategy is that the patient should survive. Patient should survive. This is all happening there. Everyone is ready in the laboratory. You know what happens is that everyone is successful in any type of cancer cell, but in actual practice it is getting reversed. That in S phase these drugs, then topoisomerase 1 inhibitors, topiticon, irinotecan. Irinotecan. These are the drugs. These are also plant drugs. Then you see epiphotophyllotoxins. These are also plant derivatives, but they are acting at G2 phase. Then bleomycin, anti-tumor antibiotics, are acting at G2 phase. So this is also one more way of classification. One more way of classification of drugs. So both you need to learn. Sometimes they ask you, among the following, which of the drug is acting at M phase or S phase, like that. So be ready for the questions. So students, any doubt here?
No.
Did you learn in pharmacology cancer chapter?
No. No.
Then,
No.
then it will be replica. Last time, how we learned cardiovascular drugs. I heard some of you telling it is like a revision, like it is for us pharmacology. They were convincing me. It will be the same. So please concentrate and read. Maybe the end of the day, try to equip. You are at home, take a chai, sorry, take a tea, take a coffee and get equipped. So please concentrate. Are you taking lecture notes? Kelvin?
Yeah, yes, I am.
Good. Sophia?
Yes, I'm taking notes.
Very good. Future doctors, you all? No. The This is the what we were discussing, DNA. This is double-stranded helical structure. See? Now, why I placed it here, you see? Now our drugs, all alkylating agents, will disturb. Usually, adenine will bind to thiamine. Adenine will bind to thiamine. Cytosine will bind to guanine. AT or TA, GC or CG. It is any way it can occur. The two nucleotides, nucleotides means base, sugar, phosphate. Base, sugar, phosphate. Both are held. This is one strand. See, for example, this is DNA strand you consider. Double helical structure. Now, this is one strand. This is another strand. Now, this is adenine. This is adenine. Adenine is combined with thiamine with two hydrogen bondings. Children, take a break for 5 minutes, please. I will come. Sorry for disturbance. 5 minutes, please. Excuse me. Please come back again if anyone is there outside. Thank you. Please sign for your attendance. 47 participants, but in attendance there is only 38. Sorry for inconvenience caused. Everyone is there, please. Please raise your hands so I can start. Oh, 26 only. Remaining all sleeping. Linda, Karaoke Patrick, Precious, Nancy, Brinda madam. Okay, no issue. So maximum are there. Thank you. This is how the bonding occurs between two DNA molecules. Two DNA strands. Two DNA strands. So this is base, this is sugar and phosphate. Together it is called as nucleotide. It binds to another nucleotide in complementary nature by hydrogen bonding. If you recollect last time, we learned hydrogen bonding. Very weak bond. Yes, Sophia, please. Okay, old one, sorry. Very weak bond, but multiple hydrogen bondings plays very important role. It becomes strong bond like that. Now you can see in DNA molecule how many between two DNA strands. See how many hydrogen bondings are there. For each pair, for example, here 2, here 3. So total 5. How many nucleotides will be there in DNA? Many. So it becomes very strong. So complementary. You see, this is hydrogen bonding donor. This is oxygen hydrogen bonding acceptor, HPA. So complementary it is forming. Now our drugs, what they do is that all these nitrogen mustards are, listen up to here, you keep in mind. Next, let us see. During our course, we'll come back again. This is these are nucleophilic groups. Nucleophilic groups. Electron rich are present here. This is nucleophilic groups. Nucleophilic groups are present here. These are nucleophilic groups. Which one? N1, N3. The numbering of adenine is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is adenine. Same way, guanine 1, 2, 3, 4, 5, 6, 7, 8, 9. These are nucleophilic groups. On nucleic acid bases, where in guanine 7, N7, in adenine it is N1, N3. For cytosine it is N3, N3. So what is happening here? These whatever we have exposed nucleophilic groups, they are rich in they're rich in electrons. So opposite uh, functional opposite substrate should have positive. Yes or no? It should have positive. So we know that positive ions will attract negative ions. Negative ions. Now what we are telling, all these are nucleic bases we are telling. Why? Because nitrogen is present. You see, all these are nitrogen bases. So what is a base nature? Having electrons in it. A base is one which accepts a proton. Yes or no? According to Bronsted-Lowry theory, base is one which accepts proton. When it can accept proton? When it is having electron rich. When it is having more electrons, it can accept. It can accept. This is a now. So this is electron rich. So our drugs will be having positive charge, electrophilic in nature. Electrophilic in nature. Electrophilic in nature. Our drugs will be having E plus. Let us see how that. Then this E plus will attract the minuses at these places in that DNA molecule. What we have told. Now, for example, when adenine binds, when our drug binds to adenine, you consider it, or for example, when it binds to guanine at 7, like this. What happens is that usually what happened, adenine used to bind with thiamine. Guanine will bind to cytosine. Now, because of this binding here, what happens is that there is mismatched base pairing. A will bind to C. G will bind to T. Will bind to T. And this binding will not be strong. Or the DNA double helical structure, which was continuous, what happened? It becomes fragments. It becomes fragments. So like this, like this, DNA. This is how our drugs will act. I hope you are following me. So these are basic in nature. So our drugs will be having acidic property. Let us see what happens. Among the alkylating agents, the first one is nitrogen mustard. Nitrogen mustards, that is this one. In classification, see what we told, alkylating agents. Under the heading alkylating agents, these are the subdivisions. The first one is nitrogen mustards that we are going to learn. No, you see, nitrogen mustard. So nitrogen mustards, I think every kitchen we use them. Mustards, we use them because they prevent it. It is in our kitchen. They prevent us from cancer, but you should not take more. I think every household will be having mustards in their kitchen. If not, in Swahili, if you want, you can type in Google and check what is the name of Swahili mustard. Swahili name of mustard. Then you can know. No, what happens is that how they done this research. It was by mistake, by chance they found this type of drugs. In First World War, mustard gas was used as war gas. It was used as war gas. However, it was found to cause atrophy of lymphoid tissues. It was causing atrophy of lymphoid tissues. More white blood cells are produced. They done the research and they formed some of the drugs. What are that? Meclorithamine. Try to pronounce this. Meclorithamine, chlorambucil, cyclophosphamide, Melphalan, carmustine, bendamustine, bendamustine. So these are nitrogen mustards. Nitrogen mustard. The simplest form of representation of nitrogen mustard is this. The simplest form is representation of nitrogen mustard is this. Now you can see bis. Bis means dye. Bis, and if you give one, 1, 2. So where is chlorine? Is present at second position. So 2-chloro ethylamine. Di or bis, 2-chloroethylamine derivatives are nothing but nitrogen mustards. So there is change. Most of our drugs will be having this structure. But there is change in R group. There is change in R group. R group is varied, but bis dichloro, bis chloro will be present. What happens to that? You see. Now let me go to next slide. We'll come back to here again. So please do not go. Why number of people decreased again? 33 came, 47 to 33. It's 423 only. My class is boring. Now you see this is one drug. What is it? Meclorithamine. What is the drug name? Meclorithamine. The drug name is meclorithamine. Is here. Previously, what we represented, we written R instead of methyl group. R we represented R instead of methyl group. Now you see, this is the our basic structure. Now what happens is that there is electronegativity difference between this carbon and this halogen. Chlorine, between chlorine and carbon there is excuse me, electronegativity difference. So what happens is that this becomes slight negative charge. So electronegative atom, no, this is electronegative atom. This is electronegative atom, there is slight negative charge. That means more electrons are pulled towards chlorine. Now here it is slight positive charge. So carbon is positive in nature. Is nature. So when it is positive, you know that nitrogen has lone pair of electrons. It has lone pair of electrons. So what happens is that this lone pair of electrons will be attracted by the carbon. So there is formation of bond like this. So when there is formation of bond, what happens? The valence at this carbon, at the second carbon, will become 5. So what happens is that chlorine will go as chloride. With its electrons, it is going. Cl, you see, with its electrons, it is going out. It is going out. Now this is electrophile. So what happens when the lone pair of electrons or nitrogen are lost? Nitrogen will get positive charge. Now this molecule is becoming electrophile. Electrophile. Now this electrophile molecule, what happens? No, it will not keep quiet. It will go and attacks the nucleophilic centers in our body. In previous slide, we have seen what are the nucleophilic centers. Guanine G7, adenine 1 and 2, cytosine 1 and 3. We have seen they will go and bind to that places. They are going and binding to that places. So nucleophile means, here, what is a DNA nucleophile group attack aziridine, or this will attack or this will attack, no problem. Nucleophile will come and attack here. Now when it attacks, no, this is having electrons. So these electrons will be used for the bond formation. This bond is formed like that. And these electrons will be taken back again. You are getting, you see, lone pair of electrons again here. This should not be there. Sorry, I will remove that. The 2 electrons are utilized for the bond formation like this. This is the new bond formed between carbon, second carbon, and nucleophile. And nitrogen has gained it again its electrons. Again its electrons. Now this lone pair of electrons will attract again second carbon, another ethyl chloride. So chlorine will go. There is formation of aziridine again. Then now aziridine molecule will attack nucleophile again, another strand DNA. So now what happens? You consider that my hand is drug. It will attract the DNA strand like this. Our drug molecule will go and attract the DNA molecule like this, 2 strands. Yes or no, students? Are you getting any doubt here?
No.
No doubt or understood everything? Not understood.
Understanding.
This is it. Let me repeat again. Some of you may not clear. Now, this is our drug molecule. First, you should understand this is electronegative atom. Electronegative atom. So the shade electrons will be more towards halogen. Halogen. Now when it is more pulled electrons, when the electrons are pulled towards it more, what happens? This carbon will become positive, slight positive, not full positive, slight positive. So because of this positive charge, these are electrons. So these electrons will be attacked here to form a ring, three-membered nitrogen ring. We learned it, that is aziridine ring. Aziridine nucleus is formed. So you see formation of reactive aziridine cation. Aziridium cation. There is formation of aziridium cation here. Now this electrophile will attack nucleophile, or nucleophile will attack electrophile. Anything is the same. Is the same. So now these bonds will go. These electrons will go. Please, I will change and upload again. The why it goes, you see, low. These electrons are utilized for the bond formation of between second carbon and nucleophile. So when it is used, what happen? Again, the same comes in. Carbon is going to get 5 bonds. Carbon cannot retain 5 bonds, so it breaks this bond between nitrogen and second carbon. So when it breaks, now what happens? It gains its lone pair of electrons again. It gains again lone pair of electrons. Now this lone pair of electrons will attract the second carbon. So it is sequence of events it is occurring. Sequence of events it is occurring in our body. Now when it is occurring, now what happens? There is formation of aziridine. So now here, with the help of this electrophile, it attacks another nucleophile. So the drug is attracting the 2 nucleophiles on 2 different strands, or it may attract even on 1 strand. So this attracting, see, it is donating alkyl groups. DNA was not having any alkyl groups in its structure. It is donating alkyl groups. So see, this is also alkyl group. This is also, this is. So that's why these agents are called as alkylating agents, because they donate alkyl groups to the DNA molecule. To the DNA molecule. So this is the way how our drugs act as anti-cancer drug. Students, clear?
Yes.
Yes. Yes.
Thank you. So just close your eyes. You need to get all these figures, these pictured structures has to come when you're sleeping, not middle of the midnight, 12 o'clock if you open. These all structures has to come. Visualize. Sequence of events if you utilize, no need to by heart. No need of any by heart. It will be very easy for you. Suppose in if you go for board exam, if they ask, suppose in oral exam for us, no, if I ask, if you may tell no, but still we pass. In oral exam, if they ask any medicinal chemist, if they come, if they ask to draw, how does this alkylating agents act? How is aziridine molecule is formed? If they ask you to explain, you can explain it. You can explain this. Now you see formation of formation of reactive aziridium cation, which can alkylate DNA. They can alkylate DNA by SN2 reaction. By SN2 type of reaction, nucleophilic substitution. So nucleophile is attacking. It is SN2 type of reaction, not SN1 type of reaction. Okay, now let us see. Let us go to previous slide and see it again. You see, ethylene moiety. What is this group? Ethyl group. Ethyl group or not? Yes or no? So that's why we written as ethylene moiety between nitrogen and chlorine is essential for activity. This is SAR. Ethylene moiety is essential for between nitrogen and chlorine. They have tried with methyl group, only with methyl chloride. They were not acting because there is no chance of formation of aziridine nucleus. They tried with propyl group, no chance of formation of aziridine. It is become lengthy. So that's why they come to conclusion that the ethyl group is important. Ethyl group is important. Now that's what we have told. They have tried with CH2 or propyl, abolish activity. When these two are there, there was no activity. So that's what we can tell as increase or decrease of ethyl groups. Causes abolishing of activity. There is abolishing of activity. So in our mechanism of action also, we have taken only halogen compounds. If we use another halogens, there is decreased activity. So the best halogen for alkylation for process is chlorine. Is chlorine. Next, R group. This is R group. What we were discussing. R group can be aliphatic or aromatic. You can be ethyl or methyl, or sometimes benzyl group also can be present. Or some amino acids you can place it. No issue. So R can be aliphatic or aromatic, which determine reactivity. Which determine reactivity, oral bioavailability, nature, and extent of side effects. Nature and extent of side effects. So this it affects them. So what we are telling, R can be either aliphatic or aromatic. So if it is aliphatic, it has different bioavailability, different side effects, different way of reactivity. If it is aromatic, it has different style. Now what happens, we see it. If R is methyl group, it donates electrons towards nitrogen. Alkyl group is electron donating. You might have learned in ortho para directors in organic chemistry. you just refer that. If R is methyl group, it donates electrons towards nitrogen, making electron rich nitrogen. So when R is electron donating, what happens? It is donating. More electrons will be available. More electrons means more way of reacting with the second carbon. So more chance of formation of aziridine. The formation of aziridine ring will be very fast. Yes or no? So the second carbon to form aziridine nucleus, faster rate. So because of this faster rate, what happens is that now these drugs cannot differentiate. The drugs with alkyl group cannot differentiate between normal cell and cancerous cell. So better is that if our group is aromatic, let me, if R, if suppose if benzene is present, what happened? The lone pair of electrons present on benzene is involved in resonance. So what happens? The formation of aziridine nucleus with aromatic ring becomes slower. Slower, less reactive, less toxic. Less toxic. So this is the advantage. If the drug is having aromatic, it shows very good activity. And doesn't mean that aromatic alkylating agents are what's it, cancer specific. It is not like that. When they given both these drugs and tested, they found aromatic alkylating agents are somewhat better. That is only explanation for this. Any doubt here, children? Any
No
doubt?
doubt.
No doubt. Okay. This time. This is about this is a now we were discussing about mechanism. You can see it. You see, just read yourself, please. Bhagavad, please.
So on the previous slide, yeah, when you have a methyl group which is donating electron to the nitrogen, so that will enhance the electrophilic character of the nitrogen. Yeah.
Electrophilic. Lone pair of electrons are increased. What he means by that?
Or it becomes more nucleophilic. Okay.
Suppose if you are coming in this fashion, no, it will become electrophilic. Yes or no? Tell.
Yes.
That is. Then anyone? Please go through this. Then I will show the pictures and everything. Are you reading or not? So I don't know how many people. Hmm? Alkylating agents are electrophilic agents. Yes or no? Because there is formation of aziridine. So they react by alkylation of important nucleophilic groups. What are that? Proteins like NH2, SH, carboxylic group, and N7. uh, Among all that, guanine N7 will be attracted more basic actually, more basic. So when they bind to this, what happens? You see miscoding, miscoding and formation of abnormal base pair of guanine with thiamine instead of cytosine is occurring. So miscoding is occurring. Previously we told G will bind to cytosine. Miscoding it is occurring. Then interstrand cross-linking. Cross-linking is occurring. Like this is double helical structure. You consider our drug is going to bind here. Interstrand it is tightly it is catching, holding like that. Then depurination occurs. Purines will be removed. Then cleavage of imidazole ring occur. Imidazole ring where it is, all the drugs, say our DNA molecules, all these are having imidazole molecules. Yes, so this is imidazole. This will be broken. When it breaks, when it is broken, now what happens is that the sugar and everything is comes in. It comes outside. Sir. Here, now you can visualize here. Here, you see, when it breaks here, you consider what happens. This totally when it breaks, this becomes totally separate entity. Like it becomes separate entity like it is going to become. Then cleavage of imidazole and DNA strand breaks and decrease in cell proliferation. DNA strand will become fragments. Double helical structure. No, DNA double helical structure. You please learn in Satyanarayana textbook. It will be very good explained how DNA replication is occurring. So it will occur in first they unwind here. So what happened? DNA is it is forming continuously. So what happens is that this red and green line which I am drawing, it will become one strand. Next, orange and red what I am drawing will become one new DNA strand. The new DNA, these two will become new DNA and these two will become one new DNA. Now what happens is that when DNA is becoming fragments, when DNA becomes fragments, what happens is that there is no continuous DNA. We know that DNA is converted to RNA. When DNA is not complete, no RNA. When no RNA, no proteins. So cell will die. Cell will die. This is this is how it occurs. You see. Now you can observe. Children, okay?
Yes.
Yes.
So this is a. You can also see miscoding how it occurs. miscoding resulting in alkylate thiamine, drug, because uh, drug has attached here. Now OH is formed, so there is extra hydrogen bonding, it is formed. Abnormal base pairing. Alkylated guanine prefers enol tautomers. Cross-linking it is occurring. Cross-linking it is occurring. So this is the mechanism of action, and with chemistry explanation, I hope you people understood. At any point, if you don't understand, you can write in our WhatsApp group, we can discuss. So now we are synthesizing what is a mechlorethamine hydrochloride. What is the trade name for this is mustragen. Mustragen. Mechlorethamine, I told. Methyl group is present, so mechlorethamine. You see, methylamine. Methylamine. This is methylamine. Reacts with 2-chloroethanol. With how many molecules? With two molecules. The name is, you see, 2-chloroethanol. Why 2-chloro? This is first carbon, this is second carbon. At the second carbon, there is chlorine. That's why it is 2-chloro. But these two means two molecules. Do not get confused. Two molecules of 2-chloroethanol will react with methylamine in presence of a base. In presence of a base, what happens is that you get dihydroxy ethylamine, methylamine, sorry, dihydroxy bis, bis dihydroxy ethyl methylamine. Now OH has to go. So you treat with thionyl chloride. You are treating with thionyl chloride. So you get mechlorethamine. So this is the what is that? Mechlorethamine synthesis. Mechlorethamine synthesis. It is used to treat Huntington's disease, different types of cancers, T-cell lymphomas. So this is any doubt here, please? No.
Excuse me, sir.
Please, madam.
Just a clarification.
Please go ahead.
So when we talked about the mechanism of action of the nitrogen mustards, so does this mean that the DNA NU can be replaced by any of these molecules, like the hydroxy the chloride molecule?
Can you repeat last part, please?
I'm asking. Does this mean during the synthesis, during the mechanism of action, you said that the DNA NU attacks on the aziridine. So in the other drugs, does it mean that the NU can be replaced by these other molecules, the hydrogen and the chlorine? So you still, for the mechanism of action, you still refer to that. I don't know if I'm making sense.
So what? I'm not getting you. So this is the synthesis I'm telling. It has
Yes.
it has to have chlorines in it. So you are telling, if you give this drug, what happens? So this chemical, if you give, what happens in our body? You want to know?
Okay, my question is it like, okay, just go back to the previous slide, like the one for the mechanism of action.
This.
Okay, you see like here, there's after the intramolecular NU attack.
Here.
So is that standard for all the drugs in this category?
Yeah.
So say the one we are working on, the one that has the hydroxyl at the chloride.
Hydroxyl will not work. It is an intermediate during the synthesis.
Oh, okay. No,
suppose if it hydroxyl group might have worked, no? Why hydroxyl group will not work? Let us see. Good idea. Already oxygen is having 2 lone pair of electrons. Can it form aziridine nucleus? Hydroxyl group is a bad leaver. You might have learned in a elimination reaction. OH group is a bad leaving group. It has to be protonated. Something has to come and attach here. Then only hydroxyl group will go. So, but whereas chlorine, no, it can leave very fast. I think you people might have learned in nucleophilic substitution, electrophilic. Please refer that. This all you might have learned. Or I too learned after going to PG, post graduation. There I learned this all. This hydroxyl group is a poor leaving group and bad leaver. It cannot be easily removed. Suppose if it want to leave, know what happened? It needs to get protonated. Something H has to come and attach here. Whereas chlorine, no, it can easily be removed. So the friendship between your friendship should be between carbon and oxygen, not between like carbon and chlorine. Chlorine can go very fast, can leave very fast. OH is a bad leaver. Leaving group. Leaver means don't tell like that. Good, bad leaving group. That's why we are converting hydroxyl group into chlorine.
Okay, thank you.
Okay.
Yes.
Now, you see one more drug. Chlorambucil. This is chlorambucil. We have, instead of methyl group, there is aromatic group. There is aromatic group and having butyric acid in its structure. It is called as chlorambucil. The trade name for this is leuceran. Is leuceran. Let us see what is advantage with this group over this drug. But you can see it in the basic nucleus what we learned. This dichloroamine group is present. This the blue portion is present. There is aromatic group and there is carboxylic group, and why it is required we can see it in. The carboxylic group improves water solubility. Improves water solubility because if you make sodium salts, it can water soluble sodium salts can be formed. So you can take orally. Oral route of administration, is it possible with this drug? Then the group bis 2-chloroalkylamine is bifunctional group. I forgot to tell. Even first, there were only one alkyl group was there. They checked that bis alkyl group activity was shown better than a single alkyl group. Single chloroalkylamine group. So dichloroalkylamine group shows better activity. Better activity. What is advantage here? This carboxylic group can be converted into salt form and it can be taken by oral route of administration. Then bis, as usual. Bis means it can attack two strands. Suppose if it is having only one alkyl chloride structure, it can attack only one strand. It cannot attack the other strand. So when it attacks the other strand, now what happens? Tightly it holds. Tightly it holds on. Then we learned what happens to aromatic ring if it is present. The lone pair present in here will be involved in resonance. So the formation of aziridine ring will be slow. It can be acting slowly. So the formation of aziridine ring is slow, and the reaction is also slow. Then it works by SN2 type of reaction. It goes through by SN2 type of reaction. Now this drug is used to treat leukemia. It is used to treat leukemia. I'm telling only main important. It is also used to treat many cancers. Among all, the main used to treat is leukemia. It is used to treat leukemia. Now, one more drug, Melphalan. Melphalan. Here you see the beauty of this drug is they where is it? They added amino acids in it. Amino acid phenylalanine group is attached. So this is our food material. Phenylalanine is a food. So cancer cell think that it is a food and it takes it. So better bioavailability was observed by this Melphalan. Then what is that? What is it? I forgot all the names. Chlorambucil. Then Chlorambucil. Why? Because it is the drug is mimicking what is that? Amino acid. Mimicking amino acid. So better easy accessibility. Suppose after 10 years, if I come to Nairobi, if I find any one of you, you will take to your home or not? Because you know me. You know me. Or if you see after 10 years your friend, will you take to your home and offer a coffee or not? Same way here also. The body will accept this drug better. Why? Because it is amino acid. So it thinks that it is a food material. So let me eat like that. But after that, real movie happening. That is because of this functional group. Okay, this is Melphalan. What is the drug? So it's a mustard. It is also nitrogen mustard drug. Example is Melphalan. So we have seen meclorithiamyl, chlorambucil, cyclophosphamide. We will see next. Melphalan we have seen. This time we will learn more in detail because the course is designed for cancer. So we are dealing in detail. In detail we are dealing. So children, any doubt? This is chlorambucil. Sorry, cyclophosphamide. This is also very good drug. So it is almost 5-5. If I start here now, it needs to be end. It's more explanation is required for cyclophosphamide. It's a pro drug. It's a pro drug. It needs to get activated. How does it activate? Let us learn afterwards. Next week we will meet. Any doubt here, please?
No doubt.
Okay then. Bye children. Take care. I'm closing. Bye.